you can always send me a screenshot of your questions and I can record a short video and put it on Canvas for you. So in this problem, we have a population function. In T years, the population of a certain city grows from 900,000 to a size P given by the population function P of T equals 900,000 plus, so that's gotta be that initial value, right? Plus, let's look, it's growing by what? 8,000 times T squared. And what does T represent in this case? T must be, the number of years from this beginning year. So part A, they're asking us to find the growth rate, dp over dt. So they're asking you to find the derivative of P, this population function, with respect to T. So you know, this notation, okay, dp dt, they're really basically asking you to find the first derivative, the derivative of this population function. So let's get it, okay? So derivative of 900,000 is just 0 because it's constant. But if you find the derivative of this term, 8,000 t squared, you will do 8,000 times 2 to get 16,000, right? And the exponent goes down to 1 from 2. So that's going to be the answer for part A. This is the growth rate, how fast the population is changing with respect to time t. Part B is asking you to find the population after 15 years. So now look, they're going back to the original function. They just want to know how many people we're going to have in 15 years. They're not asking for how fast this population is growing. So for part B, I will simply plug in 15 into the original function, okay? 900,000 plus 8,000 times 15 squared. And to save time, I'll let you figure out that number. So you're going to get like a big number, right? But you do want to put a unit, like I would say people, okay? Because we're talking about the number of people in this case. But you know what though? They just said like population. So are we talking about the number of frogs or birds in the city? I would say something about like just this being the number of people, but they really didn't say the unit here. I'll just say go with C. Go with people. All right, part C, what are they asking? Find the growth rate. Oh, now they want you to plug in that 15 into that derivative function. So you will do 16,000 times 15. And whatever number you will get, you're going to say that many people per year. Okay, and the unit is talking about how we're getting more people per year, and you know, please do multiply using your calculator when you type answers into your homework. But this number coming out as positive is telling us that this population is growing, okay? If that number came out to be negative, we're going to say, oh, the population is decreasing by that many people per year, but this is a positive number. So part D is asking, explain the meaning of the answer in part C. So I think that's what we kind of just talked about. The growth rate, this number that we get when we type this into the calculator, tells that, so they made it a multiple choice. Not from 0 to 15. What we found is actually the instantaneous rate of change at t equals 15, okay? So they're not talking about from year 0 to 15. We're talking about at that moment 15. The growth rate tells the rate at which the population is growing at t equals 15. Remember, derivative is the slope of a tangent line at that single point. So I would go with D in this case, not from looking at 0 to 15, not from looking at like 14 to 15. I would just say this is the growth rate at time equals 15, okay?